Leetcode problem 2179 called Good Triplets in an Array. So for this problem, let's just try to understand what is the meaning of the problem. After that, we're gonna use a very simple data structure in Python to solve the problem. I mean, although this is a very hard problem, but after using some simple data structure, we can still solve the problem. Or you can use a binary index tree directly. But no matter which kind of data structure, I don't think that is too hard for the data structure itself. The hard part is how can we turn this problem into our known data structure. No matter it is a sorted list in Python, basically it's a balanced binary search tree, or it is a binary index tree. Definitely, no matter which kind of data structure, we can solve the problem. Yeah, so we are getting number nums1 and nums2. So both of them are going to be n less n. And both of them are going to be the permutations of 0 to n minus 1. Yeah, it means it is a 0 to n minus 1 permutation for numbers 1 and numbers 2. Now we are going to understand what is a good triplet. So a good triplet is a set of 3 distinct values. First of all, it is a set. And second of all, it is 3 distinct values, which are present in increasing order by position both in nums1 and nums2. It means they have the same order. It has always the increasing order. Yeah. So in other words, if we consider position 1 as the index of the value v in nums1 and position 2v as the index of the value v in nums2, then a good triplet will be a set of x, y, z, where x, y, z is between 0 to n minus 1, and x, y, and z have the same sequence. That means it is in increasing order. Yeah, because like the position 1x less than position 2, position 1y less than position 1z, and similarly for position 2. So we're going to return the number of the good triplets. So let's first understand by using the first example. So in first example, in numbers 1, we have the numbers like 2, 0, 1, 3. And how many triplets? So in total, there are going to be 4. As you can see, it is a 2, 0, 1, and 2, 0, 3, and 2, 1, 2, 1, 3, and 0, 1, 3. You should know that this is not the index. This is just the numbers itself. Yeah. Now, we want to check if it is in increasing order. So for 201, so the sequence is 201, it's like that. And let's just check the last example, 013. Yeah, so for 013, and we should know that for number 1, at the left side there's a 0, at the right side there's a 3. So similarly, it should be for number 2. So for number 1, at the left side there's a 0, at the right side there's a 3. It means it is the same sequence. Yeah, because even it is not in increasing order, but the sequence is the same, so we're gonna count it as 1. Yeah. So for example, for this 013, this is 013. It means from 0 to 1 to 3. This is a sequence, and by coincidence, it is in increasing order. And for number 2, we also have 013. It is also in increasing order, so we're gonna count it as 1. Yeah. So this is the result. So we have to understand what is the meaning of the question. So we need to find some triplets. It should be in increasing order. So for example, if it is decreasing, if it is not in increasing order, we can find some other examples. Maybe let's try to check some examples in example 2. So for example, for this number 403, so this is a 4, and this is a 0, and this is a 3. So we have a sequence like 4 to 0 to 3 for number 1. It means at the left side there's a 4, at the right side there's a 3 for the number 0. Now we are going to check it in number 2. So where is the 4? 4 is also here. So, and then it is a 0, and then it is a 3. So it is like a longest increasing subsequence. Yeah. So the first number is 4, the second number from the right side is going to be 0, and after 0 there is a 3. So this means why it is right. Yeah, it doesn't mean the number have to be in increasing order. It means the sequence it has to have the same sequence. So for example, 4 0 3 for number 2, it is also 4 0 3. Yeah. So let's check this example. 4 1 2. This is 4. This is 1. This is 2. We also have 4 1 2. It also have the same sequence. It means after 4 to the right side there's 1 and there's 2. Now it seems we can solve the problem by using the brute force. But just because of the brute force, we have to use the 3 loops. It's gonna be n cubic, but this n gonna be a really big value. It's gonna be 10 to the power 5. It means we cannot use this kind of a way to the brute force way to solve the problem. Yeah. Now we are going to turn this problem into some easier problems we already know which kind of data structure we're gonna use. So first of all, we have this. I'm gonna use example 2. We have this nums 1 and nums 2. It is a permutation from 1 to n minus 1 for all the numbers. Yeah. So for each of the number, for example, this is a number 1. I'm gonna think this number 1 gonna be the middle number. Now I want to count how many numbers at the left side and how many numbers at its right side. So for example, this is 1. I found a 1. So there's a 4 at the left side for nums 2, and there's a 4 for nums 1, also at the left side of this number 1. It means there's 1 number at the left side. Now let's just count how many numbers at the right side. For this number 1, there are 3 and 2, and for this number 1, there are 2 and 3, so it means 2 numbers. So it means 1 times 2, it's gonna be 2 tuplets for this nums 1. Now maybe we're gonna enumerate nums 0. So now let's just enumerate nums 0. So for number 0, there's 1 number 4 at the left side for nums 1, and for number 0, there's 1 number 4 at the left side. It means there's only 1 number. So let's just check how many numbers at the right side for this number 0. So 1 3 2. For this is 3. For this is 0, it's going to be 2 3. So it means there are 2 numbers, 2 and 3. So it is 1 times 2 equals 2. It's going to be 2 numbers. But for this number 1, it also has 2 numbers. So 2 plus 2 is going to be equal to 4. It has 4 triplets. So we're going to return a 4. But this is not even the ON or n log n solution to solve the problem. We should know that we cannot solve it by using ON or n log n time. That means this is not enough. Yeah, because for each of the number, so for example, this is we are going to enumerate 0. We find this is a 0, but we have to find where is the position in nums 2. So it means we're gonna use ON time to check where is the position for nums 2 for this number 0. And then we're gonna count how many numbers at the left side and how many numbers at the right side for this number 0. And we also need to check if there are common numbers. Basically, it's gonna be at least n square. Even we optimize the algorithm, it means it is not possible to solve it by using n log n time or ON time. Yeah. Now we have to turn this problem into some familiar data structure we can use. So for nums 1, so why not we just turn this nums 1 to a map? It means for numbers 4, I mean the numbers, the position gonna be the same. For this number 4, this is the number 4, here is also number 4. For this number 1, this is the number 1. So we just need to turn this nums 1 into a map. So the map gonna be for this number 4. Yeah, let me first write the array. So for nums 1, we have the numbers like 4, 0, 1, 3, and 2. Now we are going to turn these numbers into the index. So for number 4, we're going to find the position is going to be index 0. Basically, we can use a map. And for numbers 1, we're going to use 1, 2, 3, and 4. So this is just the map for nums 1. Now we are going to prepare nums 2. So the nums 2 gonna be like 4, 1, 0, 2, 3. So what is the map? 4 is mapped to 0, so here gonna be 0, and 1 mapped to 2, so here gonna be 2, and 0 gonna be mapped to 1, and 2 gonna be mapped to 4, so this is gonna be 4, and 3 gonna be mapped to 3. Now what left behind is those two arrays. We just need to compare those two arrays. That is enough to solve the problem, because it is just the same idea. We just turn the numbers into a map for nums1 and nums2, but the problem already becomes easier, because before that nums1, there's no sequence for nums1. Now nums1 has a sequence. It's going to be from 0, 1, 2, 3, 4. It is in increasing order for nums1. And after turn the nums1 into a sequence for nums2, basically it is not in increasing order, but it doesn't matter, because at least for nums1 we have a sequence from 0 to n-1. It is in increasing order. Yeah. And for nums2 it's going to be something like 0, 2, 1, 4, 3. But it is okay for us to solve the problem, because after this turning, this is just on time. That is okay. Now we are going to check the numbers in nums2. Yeah, because for nums1 it has already been in increasing order and it is ordered, basically. This means, for example, for each number, let's just check every number in nums2, because currently we don't need to check nums1 because it has already been sorted. And for nums2, we don't need to check the first and last number, because we are going to check the triplets. So for this number 0, there's no triplets, definitely, because at the left side there's no number. So we're gonna check the second number and the last second number. Yeah, it means we're gonna check all the numbers like index 1 to index n-2. So first of all, let's just check this number, the index 1. So we are going to check this number 2. First of all, we're going to check the number at the left side of this number 2. So there's a 0, definitely. So we are going to check, we are going to put this 0 into a sorted list. This means, so we are going to prepare a sorted list, and we are going to check this the index 1 for this number 2. Currently this is the number 2, but we are going to put the previous number inside a sorted list, because we want to check how many numbers which is less than current number 2. As you can see, it is 1. So we're going to put the 0 inside a sorted list. So this is going to be the sorted list. Currently it has a number 0. After we put it inside, we know that after we check in this number 2, definitely we put all the previous number inside a sorted list. As you can see, 0 is inside of the sorted list. Now we can use a binary search. We can use a bisect left to check how many numbers which is less than the current number 2, because inside there's a 0. We should know there's one number which is less than 2. Yeah. So this means definitely for this number 2, there's a one number at the left side which is less than 2. And similarly for nums1, because this has already been sorted. So currently, if we are going to check this number 2, it is the index of number 2. Definitely, we should know that 0 and 1 must be at the left side of this 2 in nums1, because nums1 has already been turned to 0, 1, 2, 3, and 4. It is okay. So we don't need to check this one. We only need to check nums2. So in nums2, we find there's one number which is less than nums2. Yeah. So currently there's one number. Let me call it maybe x equals to 1. So maybe x equal to 1. This means there's one number at the left side of the current number 2. Now we are going to check how many numbers which is bigger than this number 2. Yeah. So first of all, we are going to check how many numbers in total which is bigger than 2. That definitely it's going to be 3 and 4, right? Yeah. So how can we calculate that 3 and 4? There are two numbers which is bigger than 2. So we're going to use n-1. Let me put it maybe here. Yeah. n-1. It means n going to be 5 in this example. n-1 it's going to be 4 numbers, and then minus the current number. So for this number, let me call it z, actually it is 2. So n minus 1 minus z, it's going to be how many numbers which is bigger than 2. But we need to check how many numbers at the left side which is bigger than 2, because after that we should know how many numbers at the right side which is bigger than 2, because basically our requirement is how many numbers at the right side which is bigger than 2. So we can use n minus 1 minus z, that is the total numbers which is bigger than 2, and minus how many numbers at the left side which is bigger than 2. Currently this is an index I, and we're going to use this I minus the x, because this x means how many numbers at the left side which is smaller than 2, and I is the total number at the left side which is smaller than 2. So I minus x is going to be how many numbers at the left side which is bigger than 2. Yeah, we have to understand this kind of a formula. Now we just need to use this x times the right side, how many numbers which is bigger than 2, how many numbers which is smaller than 2. So this is going to be the final result. We just need to enumerate the array and get the final result. As we are using a sorted list, so the time complexity going to be n times log n. Yeah. Now we are going to use this kind of idea to solve the problem. I think the difficult part maybe it's just about mathematics. But first of all, we have to think about the mapping idea. We have to map it, because after the mapping idea, we can ignore nums1 because nums1 has already been solved. We just need to focus on nums2, because for nums1, the numbers has already turned to like 0, 1, 2, 3, 4. It is okay, because for each number, for example number 2, there will always be a number like 0 and 1 at its left side. So for nums2, we just need to use a binary search to check how many numbers at the left side. Yeah. Now let's just use this idea to solve the problem. So we're gonna, from the sorted containers, we're gonna import the sorted list, and because definitely we're gonna use it. Yeah. Now we are going to prepare the sorted list. So it's gonna be a sorted list. And let me just prepare a result. Yeah, but before that, let me just prepare the length of the nums. So here I'm gonna use nums1, and I'm gonna prepare a map. So it's gonna be vi for iv in enumerate nums1. Yeah, so currently I have a map. It means for nums1, it has already turned to something like 0, 1, 2, 3, 4. And I'm going to prepare a final result. Now I'm going to check all the numbers in nums1 except the first number and the last number. So it's going to be from 1 to n minus 1. Yeah. Now I'm going to check the numbers inside nums2. So first of all, let me think. Yeah. So according to, I don't have the drawing anymore. Let me check. Maybe I can have the drawing. Yeah, I think it is okay. Yeah, let's just use the second example. So first of all, we are going to check the current number. It's going to be nums2, but we can use by first of all, we're going to put the numbers inside of the sorted list, but the numbers are going to be one number before the current number. So the current number is going to be nums d nums, but the number before it is going to be d nums2 with I minus 1. First of all, we're going to put the number before it in nums2 inside the sorted list. Now I'm going to prepare a z. It's going to be the current number for nums2, but I need to use this map because for all nums1 and nums2 I've already turned it into a map, so I have to use it. So it's going to be d nums2 with I. It's going to be my current number. Now I'm going to check how many numbers which is less than the current number z. So basically we can use it by the sl dot bisect left with this number z. So for example, if the current number is 2, if the current number is 2, let me just prepare something for nums2, because after third nums1 into 0, 1, 2, 3, 4, so for nums2 it's gonna be like 0, 2, 1, 4, 3. So currently, first of all, I'm going to check this number 2. So that's gonna be this 2. And x, we're gonna check how many numbers before it. It is 0. So x gonna be 1. Yeah. So x means how many numbers from the left side, which is smaller than the current number. That's the current number 2. So this is going to be the x. Now we are going to check how many numbers which is bigger than the current number 2. If you remember, it's going to be n minus 1 minus the current number z. Yeah. So I'm going to use a y to represent how many numbers at the right side which is bigger than the current number z. So it's going to be n minus 1 minus z, but it also needs to minus how many numbers at the left side which is bigger than the current number z. So it's going to be I will be all the numbers which is bigger, which is smaller than z, but I need to minus x, because x will be how many numbers at the left side which is smaller than z. And after I minus x, it's going to be how many numbers at the left side which is bigger than z. Yeah, because for this index I, it means how many numbers at the left side, how many numbers at the left side. Yeah, the total numbers at the left side minus how many numbers at the left side which is smaller than the current number. So this is going to be how many numbers at the left side which is bigger than the current number on z. Yeah. I'm not sure if you are easy to understand this kind of idea. Maybe I'm going to use an example. So for example, the current in this example, the x for this number 2, it's going to be 1. So x equal to 1. It means there's one number at the left side which is smaller than the current number 2, because that's going to be 2. Now we're going to check how many numbers at the right side which is bigger than 2. So n minus 1 minus z is going to be equal to 2. Yeah, so here going to be equal to 2. It means the total numbers which is bigger than 2. Now I need to minus the I minus x. So I means 1, I equal to 1 because it is currently index I. This means at the left side how many numbers. This means so the I means how many numbers at the total numbers at the left side. Yeah. So because we are going to check this I, actually this I is just because the current number nums I equal to 2, that is equal to the current number. But we are going to check how many numbers which is which is not equal to 2. Actually, it is the index I. It means the total numbers which is not equal to the current number. It means basically means at its left side, how many numbers at its left side. And then we're gonna minus how many numbers at the left side which is smaller than 2. So it means I minus x gonna be how many numbers at the left side which is bigger than 2. So the total number minus the number which is bigger than 2 at its left side. It means it's gonna be how many numbers at the right side which is bigger than 2. I mean, this is difficult to understand, and this is the hard part of the problem. Basically, we need to know how to deduct this kind of a formula. After that, we can solve this problem easily. So now we can put it inside the final result, and it's going to be x times y. And finally, we just need to return the result. Now let me just run it to check. As you can see, it works. Now let me submit it to check if it can pass. As you can see, it passed all testing cases, and it's pretty fast because the time complexity is just n log n. Yeah, because we already used this kind of a sorted list idea, and we've already used this map idea. I think the difficult part may be first of all, it is the map. Yeah, and second of all, how can we detect this kind of a formula to check the numbers which is smaller than the current number, or at the left side which is smaller than the current number, or at the right side which is bigger than the current number. Yeah, and then we directly use this kind of formula to get the final result. Thank you for watching. See you next time.